All right, so welcome back to the geotechnical engineering portion of the review for your Civil FE exam. Today in this video, we're going to be diving into phase relations. And so I have some practice problems for you all that I want to go ahead and jump into. All right, so number one says, using the following information, what is the void ratio? So they give us a volume of solids is equal to 150 centimeters cubed. Volume of water is 50 centimeters cubed, and then the volume of air is 30 centimeters cubed. All right, so where do we start? Okay, so we first start by writing down the given information. They give us the volume properties of the sample. Okay, so we're trying to find the void ratio. Okay, so how would I do this? Well, first thing I would do is search void ratio. And I get to once I search that, I get to the geotechnical engineering section, and they let me know that void ratio is equal to VV over VS. Well, what is VV? So VV is going to be volume of voids. Okay. All right. And so volume of voids over volume, VS stands for volume of solids. Okay. So CVS is for solids. VW, this diagram helps too. VW, volume of water. VA is volume of air. Okay. So just some things to note. Okay. So if I know that my void ratio, so the formula I can start with is E. I'm solving for my E is equal to volume of voids divided by volume of solids. Okay. Do I have my volume of solids? Yes. So is equal to my volume of solids is 150 centimeters cubed. Okay. What about my volume of voids? Well, volume of voids up here. Volume of voids is equal to, they don't give us volume of voids, but they do tell us that in our handbook that volume of voids is equal to volume of air plus volume of water. Now, do they give us volume of air and volume of water? Yes, volume of air, volume of water. Okay, so volume of voids is equal to 30 centimeters cubed plus 50 centimeters cubed. So I get from my volume of voids 80 centimeters cubed. Okay, so now I can plug that into my equation, 80 cm cubed. And so now I should be able to get the rest of my equation, or plug this in to get my answer, which is 0.53. Okay, so answer is A. All right, let's look at number 2. So this one says, using the following information, what is the degree of saturation? Volume of solids, 400 meters cubed. Volume of water, 100 meters cubed, and volume of air is 50 meters cubed. Okay. So we are given the volume properties of the soil, right? And we are trying to find the degree of saturation. All right. How do I get degree of saturation? Degree of saturation. I just search and see if that'll help me. One thing comes up when I search for that. So a big thing is knowing what to search, right? If you know you're trying to find a certain variable, like they tell us to find the degree, it says what is the degree of saturation, then I would search degree of saturation if I didn't know the formula, right? And that's the first thing that, ironically, this is the only thing that comes up, but sometimes that's not the case, right? Okay. So we can look at this and say the formulas that it looks like that we need, our degree of saturation is going to be S is equal to volume of water divided by volume of voids, okay, times 100. Do we have, or it would be W times GS over E. And so the weight, so W is the water content, right? And it's saying W of W, so the weight of water divided by the weight of solids. We don't have any of that, so I don't even want to use this second formula. I want to use this one. Right? So I would say the formula that I need, and if it doesn't work, right, we'll come back to the drawing board, but S is equal to volume of water. I want to make my job as easy as possible, right, when I'm solving this. Volume of voids times 100. Okay. This is my degree of saturation. Okay, so do I have the volume of water? Yes. So this is equal to 100. So my volume of water is 100 meters cubed, right? Divided by, do I have my volume of voids? Volume of voids is equal to, no. So what is volume of voids again? Volume of voids is equal to volume of air plus volume of water. Do I have volume of air and volume of water? Yes. So volume of voids is equal to 50 plus 100, which equals 150 meters cubed. Right. This is all cubed. So okay. So let's plug that in. $100 divided by 150. So I get 66.7% for my degree of saturation. So I get B. Let's look at number 3. So this one says, what is the specific gravity of a soil sample that was collected and subjected to laboratory tests? the following data is available. You got the volume of soil solids is 0.02 meters cubed. You have the weight of dry soil solids, which is 600 newtons. Okay. So we're given the volume and weight of the soil, just the solids, right? And we're looking to find the specific gravity of the soil. All right, so any formulas that we might need? Well, I'm in the right section, I do believe. So specific gravity of soil solids, right? It's here. So we need to, so we would use basically weight of the solids divided by volume of solids. So do we have weight of solids? Yes. Do we have volume of solids? Yes. Do we have the unit? What's this? Y sub W. That's the unit weight of water, which would be 9.81 kilonewtons per meter cubed. So we have that information as well. That's given in the handbook rather. So we have all the variables that we need to be able to solve this. So I could say GS is equal to W S divided by VS, all divided by the unit weight of water. All right, so WS is the weight of your dry solids, which is 600 newtons, divided by my volume of solids. That's my volume of solids. I get 0.02 meters cubed for that. That was given. And then what is my unit weight of water? Well, it's going to be our 9.81 kilonewtons per meter cubed. But if you notice, we want our units to cancel because our answer doesn't have any units. So if I want my units to cancel, I need to get everything in newtons and in meters. So I currently have, if I put this in as 9.81 kilonewtons, that's not in newtons, it's in kilonewtons. I need to get that to newtons. So to do that, kilonewtons just means 10 to the third, right? Kilo. So I would say 9.81 times 10 to the third newtons over meters cubed. And when I do that, I get 3.05, right, or D. All right. So this concludes the phase relations section of the geotech review. In the next video, we'll be looking at laboratory field tests.